Hi there! So, the question asks, H2SO4 sulfuric acid is considered a strong acid. How would you categorize its conjugate base SO42? Now, first of all, I think there's a problem with your question. SO42 should be written as SO42 minus, and I'll show you why that is in just a moment. Now, here's the structure of H2SO4 sulfuric acid. You can see your 4 O's, your 1 S, and your 2 H's. This is the most highly stabilized resonance form of H2SO4 because everything here is neutral. In order to be neutral, oxygen likes to have 2 lone pairs and 2 bonds. And you can see that every oxygen here has that. 2 lone pairs, 2 lone pairs up here, and 2 bonds. Now, H2SO4, when placed in solution, especially basic solution, likes to lose protons or lose hydrogen atoms. We can say both. We can think of a hydrogen as being a proton because hydrogen has a +1 charge. Now, when H2SO4 is placed in a basic enough solution, it will lose both of those hydrogen atoms and become SO4 2 minus. And this is how it happens. You lose these hydrogens, and now you have these lone pairs on oxygen because those bonds can't stay like that. They're not attached to anything. They become lone pairs. Now, I said earlier that oxygen likes to have 2 bonds and 2 lone pairs, but now each oxygen here has 3 lone pairs each, which makes both of these oxygens negative. They both have negative charges now because they have more electrons than what they would normally like to have. They're not sharing those electrons with anything now. And here is the structure mentioned in the question, SO4 2 minus. Or, it should rather be written like this. So, anytime a strong acid loses its protons, it becomes a weak base. Basically, the conjugate base of a strong acid will always be weak. Just like the conjugate acid of a weak base will always be strong, and the conjugate acid of a strong base will always be weak. Basically, you just have these opposite words you can assign to conjugate acids and conjugate bases, weak and strong. So a strong acid, like sulfuric acid, will have a weak conjugate base. So the best answer is B. The answer is not Arrhenius base because an Arrhenius base is a base that when placed into solution increases your hydroxide ion, your OH minus. This would not increase the amount of OH minus in a solution because it has no OH minus. And a Bronsted Lowry base is one that would accept a proton, which is true of this base. It would accept a proton, but that's not the best answer. Basically, anytime you see that you have a strong acid, you have a weak conjugate base. I hope this helped. Thank you, and good luck.